Hey guys, it's Miss Johnson here to bring you your Unit 8 Notes 5 video on the Pythagorean theorem. Today our objectives are to simplify radical expressions and also to apply the Pythagorean theorem. Simplifying radical expressions is the same thing we've been doing all throughout Unit 8. Remember that you can take the time to read the word problem on your own before we start going through it. Up at the top, we are looking at the Cyclone roller coaster at Coney Island in New York. And we are asked to find the length of the first drop, the length of the first hill that drops in the roller coaster. The things that you're told in there is that the first drop is 85 feet tall. And you're also told that the length from the bottom of the roller coaster to the bottom of the first hill is 147 feet. So we have two sides of the roller coaster and we're supposed to find the length of the hill. The best thing you can do here is to draw yourself a picture. So I'm going to set up the roller coaster. Here's the top of my roller coaster. It's going to go down to the ground and it comes out here. Now the roller coaster actually goes down this hill right there. Okay. Assuming that the top of the roller coaster and the ground make a right angle, we have a right triangle. So we can use the Pythagorean theorem in order to solve this. So I know that the top is 85 feet above ground, and I also know that the length from the bottom of the roller coaster to the bottom of the hill is 147 feet. I'm missing the C value. The C value is always the hypotenuse, it's always the longest side, it's always by itself on the Pythagorean theorem. So I have, if I set this up, 85 squared plus 147 squared is equal to C squared. I can plug all that into my calculator. 85 squared is 7,225. 147 squared is 21,609. And C squared there. Adding them together, I get 28,834. And I want C by itself. So remember, to unsquare something, I have to take the square root. Or in other words, to cancel that power of 2, I'm going to take the square root. Taking the square root of that number, I get that C is approximately, remember that approximately equal to sign that we talked about, 170 feet. So that's the length of the first hill that you go down in that roller coaster. Now let's just review the Pythagorean theorem for a second. For those of you that have forgotten, if I have a right triangle, meaning that there is somewhere in the triangle, one of the three sides makes a right angle, I can use the Pythagorean theorem, which tells me that the square of the first side plus the square of the second side is equal to the square of the third side. Now, the one thing we have to be careful of is that the two sides that go together to be added, this A right here and B right here, these are the legs of the triangle, and C is always the hypotenuse. Now, if you don't remember that word hypotenuse, that just means that it's the longest side. Longest side. It also means that it's across the right angle. Across from the right angle. Okay, so that's how I use that's what the Pythagorean theorem is. Now, a Pythagorean triple, if we're given three side lengths and we put them into the Pythagorean theorem and they satisfy it, it works, then they form a right triangle. We call that a Pythagorean triple. And we'll take a look at some examples of what that might look like. Let's try number 1. In numbers 1 through 4, we're supposed to find the missing length of the following right triangles. In number 1, we have A and B, and I'm looking for C. Okay, so if I plop that into my Pythagorean theorem, I have 8 squared plus 15 squared is equal to C squared. Again, that C is always by itself. 8 squared is 64. 15 squared is 225. And C squared is over here by itself. Adding those together, I get 289. And then again, to unsquare something, I have to take the square root. Now you can go ahead and check in your calculator, is 289 a perfect square? And it is. We come down to 17 equals C. If I look at number 2, I have A and B again. So A is 18, and b is 24, so I have 18 squared plus 24 squared, and I'm trying to find c. C is my question, or c is the missing length. 18 squared is 324, 24 squared is 576. Adding those together, I get 900, and when I take the square root of 900 is 30. Okay, so let's take a look at number 3. In number 3, I have a and c now. A and c is what I'm looking at. So I'm missing b. That's my question there. So if I put this into the Pythagorean theorem, that means I have 10 squared plus b squared is equal to 25 squared. When I solve for that, 10 squared is 100. 25 squared is 625. And then I can subtract the 100, leaving me with b squared equals 525. Now, when I take the square root of both of these, I get b alone, which is what I want, but the square root of 525 is not a perfect square. It's not a whole number, so I need to simplify this radical. I'm going to break this apart just like I've been doing all unit long. So 525, I broke apart into 25 and 21. 25 times 21 gives me 525. So if I keep going with that, 25 is 5 and 5. 21 is 3 times 7. So there's my prime factorization. So here I have b is equal to the square root of 3 times 5 times 5 times 7. And then taking out the pair that I can take out a 5. I get b equals 5 times the square root of 3 times 7. Or in other words, b is equal to 5 times the square root of 21. So that's my simplified radical there. I want you to go ahead and pause the video at this time and see if you can figure out number 4. Let's move down to number 5. In 5 through 8, we're supposed to determine whether the following side measures give us a right triangle. So these are those Pythagorean triples that we were talking about. I need to drop all of these into the Pythagorean theorem and see if they work out for me. Now, one thing to keep in mind is that the longest side is always the hypotenuse. So I need to look at the 3 numbers I'm given. In this case, 20, 21, and 29, and find the longest side. The longest side is 29, so that has to be my C. That has to go in the spot for C. So I have 20 squared plus 21 squared equaling 29 squared. And this is what we're asking. Is that actually true? If that's true, then they make a right triangle. If it's not true, then they do not. So let's check it out. 20 squared is 400. So I get 400. 21 squared is 441. And 29 squared is 841. If I add those together, 400 and 441 is 841. And the question is, does 841 equal 841? In this case, yes, it does. So your answer here is yes, they do make a right triangle. Let's try number 6. In number 6, I have the 3 side lengths, 8, 10, and 12. And again, the longest one is always the hypotenuse, so 12 has to be my C. So if I put those into the Pythagorean theorem, I have 8 squared plus 10 squared equaling 12 squared. And again, the question is that true? Do those things actually equal each other? So for 8 squared, I have 64. 10 squared is 100. 12 squared is 144. If I add those together, I end up with 164 equaling 144. Well, we all know that that's not true. So if those two things don't equal it, then these don't make a right triangle. These 3 side lengths are not a Pythagorean triple. I'm going to set up number 7 for you. In number 7, again, I'm looking for the longest side. 16 is it, so that has to be my C. So I start with 9 squared plus 12 squared equaling 16 squared. And again, we want to ask, is this true or not? I want you to finish that one on your own and see if you can also complete number 8. So finish off number 7 and try number 8 on your own. That's going to conclude our notes video for today. Don't forget to pop back over to Schoology and take your quiz. I hope you have an awesome night, and I will see you all tomorrow.